All right, hello, my wonderful students. This is section 5.2, Foldable 3, multiplying and dividing rational expressions. And it looks like we're going to continue with some other multiplications, divisions of rational expressions here. So let's go ahead and zoom in and get started with this one here. Right about there or so. All right, first one again, we have x squared plus 6x minus 16 divided by x squared plus 9x plus 8, and we're going to divide it by x minus 2, but once again we're going to go ahead and just put this over 1 so we have another fraction to do it. This is going to be a rational expression division of polynomials. So let's go ahead and just factor everything first. So let's go ahead and just factor everything. It looks like we can only factor these two. It looks like these two are already kind of factored all out. But then we're also, after we do that, we're gonna multiply by the inverse. Because remember, we are doing division, so we're gonna have to multiply by the inverse. So let's go ahead and do our two factors that we need to do. First one is negative 16 and positive 6, and then we have 8 and 9. I love when it's like 8 and 9, or 9 and 10, 10 and 11, because it's just going to be 1 times that number, and they're both positive, so that works out. 16, and it has to be 8 and 2, and looks like 8 has to be positive because the 6 is positive and the 2 has to be negative, so 8 minus 2 is going to equal 6, so that kind of works out for us. So now we're going to go ahead and write this. So this equals, put our factor on top. The factor on top was this one here, so it's x plus 8 and x minus 2 divided by our x plus 1 over our x plus 8. And once again, we're going to multiply here, and we're going to multiply by the inverse, which making this 1 over x minus 2. Once again, since we are multiplying, it kind of just multiplies across and multiplies across on the bottom. Oh, I forgot a little, sorry about that. I forgot this little close parentheses here. So this technically is all being multiplied together. That means I can go ahead and do this, x minus 2, and say these can reduce. Then I'm also going to get these x plus 8s here. And these also reduce as well. And this leaves me with a grand simplified form of 1 over x plus 1. And remember, this is the simplified product. Simplified product. What an amazing simplified product it is. Which is cool, because now all we have to do now is look for the excluded values. Once again, we're going to use the excluded values here. So we're not going to use the excluded values of the original. We're going to use the excluded values of the, so let's just write that up. So to find the excluded values, or the domain, we will use the original products denominator. So we're using the original products denominator. Cool, that kind of makes it work. All right, so what is it? So we have our x plus 1, our x plus 8, and our x minus 2. We're going to set all these equal to 0. Alright, so if we do that, we can just write x minus 1 equals 0, or sorry, x plus 1 equals 0, x plus 8 equals 0, and our trusty x minus 2 equals 0. Alright, so once again, minus 1, x is equal to negative 1, minus 8, x is equal to negative 8, and plus 2, x is equal to 2. So now we have our 3 excluded values, so we can go ahead and write, therefore, the simplified form of product, I keep saying form, but it's product, is, and what was it? 1 over x plus 1, where the domain is all real numbers, where x cannot be -1, -8, and 2.